right, good morning, everyone. It's 9 a.m. here in Eastern Time, and we're ready to get started with this year's online MiCorps Cooperative Lakes Monitoring Training. I'm Joe Latimore. I'm going to help us get started this morning. What you should see on your screen is a slide that tells you all about what we have planned for you today. We have a full day of training available. You're welcome to come and go as you wish. Attend the sessions that you're interested in. We will stay on this schedule, so you can refer to this schedule, and it's also on the website, so you should have seen it there if you need to leave and come back. We have a few instructions on here on how to have the best experience using Zoom. I'll mention there on the right, you should be hearing me now. If not, you're here seeing my mouth move, but there's instructions on the screen on how to adjust your audio, make sure things are coming through your speakers. If you want to ask questions today, you'll see on the bottom of your screen, typically you'll find a little chat icon there, and you can see it being circled. You can click on that and you can type into the chat any questions that you have. We'll all see them. Everybody will see them. And so you can use that function to ask questions of the audience and of the presenters. And if you have any problems, you'll see there's a help desk. You might want to jot down that phone number. Problems are rare, but you can call MSU if you have problems with the technology, and they have staff on hand that can help you with that as we get going. Eric, was there any other technical details we should mention here at the beginning?
I think you got it all.
All right, great. Well, let's get started then. I'm going to hand the mic over to Tamara Lipsey from Eagle to kick us off.
Hello and welcome everyone to our 2024 Cooperative Lakes Monitoring Program training. This is an opportunity for me to welcome you all. Thank you so much for coming. If it's your first time or if it's your 10th time, I appreciate you being here. Next slide. My name is Tamara Lipsey, and I'm an aquatic biologist with the Michigan Department of Environment, Great Lakes, and Energy. I am the MiCorps person for Eagle. So MiCorps is what I do with a majority of my time, but I also do get to do sampling throughout the state. I've worked with Eagle for 21 years now. So I've gotten to do a lot of lake sampling, but also a lot of stream sampling and fish sampling as well. And then in the bottom, there's a picture of me doing some snorkeling for invasive species. Next slide. I just wanted to let you know how the CLMP program, along with the other MiCorps programs, are funded. Eagle is the funding agency, but the funding source is Renew Michigan, which is a state general fund. Our stream cleanups are also funded through special water quality license plates. So if you get one of those license plates with the little boat on them, that part of that money goes to our cleanup programs. So if you enjoy the CLMP program, I encourage you to contact your state representatives and let them know that you appreciate general funds and the Renew Michigan funds to be spent on our program. We have a 5-year contract with Michigan State University, which is both Joe and Eric, plus there's a couple of other GIS staff from MSU that work on our program. And then we have 2 subcontracts with the Huron River Watershed Council and Michigan Lakes and Streams Association, both of which who have been with the program for a really long time. And it really takes teamwork because we have a private or a nonprofit entity, a university, and a state department. It really works well for all of us to be involved. Next slide. Just to give you a little idea of how the MiCorps program is organized, under MiCorps, we have the Cooperative Lakes Monitoring Program, which you're here today, of course, but then we also have a volunteer stream monitoring program and a volunteer stream cleanup program. Next slide. We are celebrating 50 years this year. We're really excited about that. We're the second oldest volunteer monitoring program in the country. We have an online database that's available to all of you. And the data that you all collect is used by many people, both your own lakes to make management decisions that are informed by data. And then also both Eagle and the DNR and other universities and other entities also use the information. Next slide. Just to give you an idea of how Eagle uses the data, we have to turn in a report to the US EPA every 2 years. And in 2024, which it just got approved last week, we were able to include data from many of our CLMP lakes. So in 2022, 199 lakes collected total phosphorus, 161 collected chlorophyll, 275 collected SECI, and 115 lakes collected all three. And could you click one more for me? So in our 2024 integrated report, we were able to give updates on 250 lakes based on the CLMP data. And that's 250 lakes that we would not have been able to report water quality on because Eagle can only go to maybe say 20 a year. So your data is really important. I want to stress that, and we appreciate you. Next slide. Finally, I want to introduce the rest of the staff, some of which you'll be seeing today. You heard Joe Latimore and Erick's voice. They're both with Michigan State University. I'll let them introduce themselves. Paul Steen is with the Huron River Watershed Council. He's in charge of our stream monitoring program and also helps out with CLMP and will be presenting later this afternoon on chlorophyll. Melissa DeSimone, Mike Gallagher, and Jean Roth are all with Michigan Lakes and Streams Association. Melissa helps promote our program and supports our program. Jean is our logistics guru and sends you all those supplies that you need and is invaluable. And Mike Gallagher is the current treasurer for MLSA, and he provides an important viewpoint of a volunteer himself because he volunteers on his lake, Coal Lake. Next slide. And with that, I'll turn it over to Joe.
Thanks, Tamara. It truly is a team program, everything we do in MiCorps. And so it's always fun to be able to get together. We were in person last week in Muskegon at the MLSA conference. And then even when we're together online with all you folks, it's a really kind of exciting way to kick off the monitoring season. As Tamara mentioned, my name is Joe Latimore. I'm at Michigan State University, where I'm a faculty member in the Department of Fisheries and Wildlife. And I'm also the director of the MSU Extension Center for Lakes and Streams. And I spend a lot of time, although not as much time as I would like, on our lakes and streams across the state, working with a lot of folks who care very much about their waterways. And so I'm really glad to be part of the MiCorps program. I've been involved with our stream and lake programs for almost 20 years now. So it's a real exciting program. And every year I look forward to kicking off the season with you. Next slide, please. Tamara hinted at the amount of data that CLMP volunteers contribute all over the state. Here's a map that shows the distribution of lakes in the program. And one thing I really want to point out that's exciting, and I know we have some folks that monitor lakes in the UP on today. A few years ago, if we had shown this map, there might not be any dots at all in the UP. We're really excited to see the adoption of the program in the Upper Peninsula. We've been intentionally spending more time up there and working with folks across the Upper Peninsula to just raise awareness of this program and share the benefits that it has for lake protection, lake management, lake conservation. And so while we're seeing growth statewide in the program, it's really nice to see the map have more dots in the north. You can find all of the data collected by all our lake monitors and also all of our stream monitors on the MiCorps website, micorps.net. See that little red arrow on the screen? You can find our data exchange there. And if you click on data exchange, you will be able to find all of the data for the entire history of the program. So you can look up the history of your lake or lakes around you that you're curious about, dating all the way back 50 years. So it's a really valuable resource for the state of Michigan and for communities locally like yours. Next slide, please. Also on our website, you'll find a lot of other resources. There's an example there of one of our fact sheets. We have them developed for each of our CLMP parameters. So if you're curious about, like, why would I want to monitor this in the first place? Why should I care about chlorophyll, for example? This is a one-page kind of summary of what it is and why it's important. This can be also really valuable if you're already monitoring. You can use these fact sheets to share with your neighbors, your lake association, or decision makers in your area. It'll help explain what these numbers mean and why you're doing them. So this is a really handy resource that we make available on our website. You'll also find all of the instructions and protocols that we're going to talk about today. You can find them there. You can read them online. You can print out copies if you want to have a copy out on the boat with you. It's a great resource there. And then you can find our historical reports, all the data forms, schedules for when you need to turn in samples. You know, we mail you a lot of these things if you're signed up, but it's also good to know that if you lose it or you don't remember exactly all the details, you can find all of the stuff on the website. And finally, I'll mention we have training videos on the website. We're recording this today. And so right now, last year's online training recordings are all on the website, but we'll be updating those in the next couple of weeks with this year's. Not much has changed. We also have actual film from out in the field for some of our parameters, and you can see volunteers kind of doing the sampling. So if you want to take a look and see what that actually looks like, all of those resources are on our website. So we hope you'll check them out. Next slide. The last point we want to make today, we have a lot of information to go through, and this is the Cooperative Lakes Monitoring Program. So we're going to focus on training you on the monitoring procedures today. We've been doing this again since 1974. It's our 50th anniversary. We're really excited about that. And we're going to stay focused on monitoring today. Sometimes it's tempting to want to ask questions about your lake and management questions you might have, you know, asking for insight on why you might have seen some algae blooming on your lake, or you're not sure what to do about your zebra mussels. And we would love to talk to you about that, but not today because we have a lot to go through. So please forgive us if we shut down any questions like that. You're welcome to reach out to us outside of today's training to answer those questions or help direct you towards resources. But today we're going to stay focused on monitoring. And with that, it's a great segue to move you over to hearing from Erick about a little introduction to why we do the monitoring that we do. Take it away.
Thanks, Joe. Hello, everybody. I'll give a little bit more introduction to myself in the next presentation, but I'm Erick Elgin. I am an aquatic ecologist with MSU Extension and the CLMP Lakes Program Manager. And so, as Joe mentioned, I'm going to just finish off this introduction and welcome with a little bit about what we do here in the CLMP and some why. So as has been alluded to by Joe and Tamara, is that we've been collecting data for a long time. Since 1974, we've been collecting Secchi disc water transparency. And so we are, and then since 1974, we've added more and more parameters, and we are a long-term lake monitoring program, collecting various aspects of lake ecosystems. And what does that mean? What does that look like? And I love this figure. Maybe it's not the most helpful in interpreting, but what I'm showing here is a the Secchi disk readings from Long Lake in Iosco County, which has been collecting Secchi disk depth through our program since 1974. The exact same way since 1974. And that part is really important because being the exact same way, we get to compare apples to apples through time. And that's what makes this program quite unique. And so to understand our lake ecosystems, which are very complex, having 1 year of data is great. Having 3 years of data is great. But now with this long-term perspective, we can start to get a glimpse that can help us understand our lake, help us with management, and grow an appreciation of this really cool place that we live and enjoy on. And so just to show you this figure, what is it showing? So here from the this is so each one of these bars is somebody dropping in a Secchi disk into the water and collecting water clarity. There are over 700 Secchi disk depths that have been measured by this lake through time, through what I would call generations of volunteers. So somebody started in the 70s. Likely the lake enjoyed it. They enjoyed it so much that they helped a new volunteer take over, and that probably happened through the decades to now here we are today in 2024, where this lake is now signed up again. And what's interesting is the Secchi depth readings were above 10 feet, but the water clarity has actually started to increase in this lake over the last 20 years, which, when you put into perspective, people might say, I've lived here for 20 years. My lake has never looked like this. So now you can imagine now having good data that has been the same protocol through the years. Now it's valid to say, well, actually, the lake has changed, and they changed in the late 80s and 90s, and here's the data to show it. So in order to have that quality long-term data, consistency in protocol and collections is very important to maintain that data quality. And that's why we have these trainings. Joe talked about all those resources to help all of you collect the data, and then also the other resources, us. And we're available to answer those questions if you might have them about protocol or how to do something. So in the CLMP, we tried to measure a lake's condition through time, and we measure a lake's condition by looking at water quality parameters, shoreline and nearshore habitat parameters, and we also look for aquatic invasive plants. And so with our water quality parameters, we look at water clarity, which is Secchi disk. We look at phosphorus, which is a key nutrient to algae and plant growth in lakes. We look at algae itself, but we look at it through the measurement of chlorophyll A. We also look at dissolved oxygen and temperature, as that how the temperature is through the water body really dictates a lot of the chemistry and physical aspects of the lake. For shoreline and nearshore habitat, we have score the shore. So that score the shore is where we are measuring how much development, how much erosion, or how little erosion there is. How about the woody habitat? What's going on with the aquatic plants? And we put that all together to give scores on the shoreline. If you really love plant identification, we have an aquatic plant mapping parameter where it's a quantitative survey where we measure we collect what aquatic plants are in your lake, where and how much. And then dissolved oxygen and temperature go into the habitat section too, because if anyone lives on a cold water lake, that's a lake where fish require high amounts of oxygen lower in the lake. And so by measuring temperature and oxygen, we can measure the habitat that is available for those types of fish. And then finally, for aquatic invasive plants, we have the Exotic Aquatic Plant Watch, which is an early detection survey for aquatic invasive plants. So if you're concerned about the new entry of a species, this is a program for you. So when we collect this data, we we get that individual year. Thank all of you. You're entering a tradition on our lakes here in Michigan of long-term data collection. But so what we do is we supply you that 1 year of data. So here's an example of in 2023, this lake in the program, they measured phosphorus and they got 46 parts per billion. So we give that to you. But now to help reference what does that mean, we first of all give you some background on it so you'd get that, but then we also compare it to other lakes. So the average phosphorus concentration for CLMP lakes is actually 17.4 parts per billion. So now when you compare, you can say, wow, we're high. Let's say this is our lake. So you can compare it to other lakes. And then if you have phosphorus readings through time, now you can start to say, well, you compare to other lakes and you compare through the years. And so here's a summary figure where this is phosphorus on the vertical axis, and on the horizontal axis, we have time. And so they've been collecting phosphorus since 2000. And as you can see, there's just this general linear trend of increasing phosphorus levels in the lake. But to give even further context to the data, we take water transparency, so that's Secchi water transparency, total phosphorus, and chlorophyll A. Chlorophyll A is that measure for algae. And we actually put those numbers into equations and put them, and then that number spits out what lake type are you? And what we call that is for trophic status. And so we use these 3 parameters to tell us what's your trophic status. And trophic status is it's the measure of how productive your lake is. And what I mean by that is how much growth can occur in that water body. So on the left-hand side, you see this image of crystal clear water, low algal biomass. I'll just make something up and say low plant biomass too. And we'll say, well, there's not as much growth that is happening in that lake. But then on the right-hand side, we see a lot of algae in the water. And this so happens to be a cyanobacteria in the water. And this has a lot of production or productivity. There's a lot of algae growth here. So to show you what these numbers then mean, we use the Carlson's trophic index. Like I mentioned, we put these numbers into an equation and it gives us it puts us into a continuum and gives us an understanding of the lake. So the first bucket that we put it in is what's called oligotrophic. So if you are in a oligotrophic lake, that lake is usually very clear water. You likely have oxygen throughout the water column in the summer months. And actually you might have more oxygen deeper in the water than you do above in the top parts of the water. And there's typically low algae and low plant biomass in abundance. And here are the numbers of water clarity, summer phosphorus, and chlorophyll that correspond with that. So for example, to have your water clarity measure as oligotrophic, you need to be able to see this disc in the water over 15 feet down. So pretty clear water. The middle bucket is called mesotrophic. At this point, the water clarity is not as high. You might start to lose oxygen in the water column in September, or lower in the water column in August and September. And now you're getting a bit more plant biomass. You might have some algal blooms here and there. And as you can see, the measurements are now kind of in the middle. Where I'll just move forward to show the comparison is finally our eutrophic bucket. So in eutrophic lakes, we typically have lower water clarity due to higher amounts of algae growth. We have loss of oxygen in the hypolimnion, which is the lower part of the lake. And then you might have either lots of plants or no plants at all. And so why we get a loss of oxygen in the lower part of the lake is when there's a lot of algae growth up top, there's also a lot of death. They don't live very long. And so they die, fall to the bottom of the lake where they're decomposed. And when they get decomposed, they actually use up oxygen. And so you get oxygen depletion in the lower part of the lake. And now so to put a long-term monitoring perspective on this is lakes can be stable and stay in their trophic status through time, but they can also move more eutrophic or more oligotrophic. And so lakes can naturally move in either direction. Lakes are also naturally in all three buckets. One bucket is not, or one trophic status is not better than the other. It's just that the lake is different. Now, if we see a dramatic increase towards eutrophic waters, and we show that in the data, and this lake so happens to be developed or in a developed watershed, that is what we call cultural eutrophication. So that is a lake that is becoming more eutrophic due to human activities. And in that case, that's where our data is used to motivate action to hopefully pause that trajectory. Now, lakes can also become more oligotrophic, and that's called oligotrophication. And that can be caused naturally too, or by human actions for the better. It could be that phosphorus pollution has been reduced. For example, let's say lawn fertilizers aren't used anymore and septic systems are all fixed. And so there's not as many nutrients going into the lake. And so therefore, through time, the lake can become more oligotrophic. But it also could mean that your lake has been invaded by zebra mussels. And now that's not a good thing because it's collapsing the water, the food web within the lake, and we are becoming more oligotrophic. I want to finish off this part of the presentation now with talking about our other parameters in habitat and aquatic invasive plants. So Joe is going to be talking about this later this afternoon about Score the Shore, but just to show the importance of collecting data through time is to get an understanding of how our lakes change through time. And our shoreline habitat, which is pivotal for the functioning of our lake ecosystem, has in some lakes changed in a dramatic fashion. And here's an image just to showcase what can happen on the shoreline of a lake. And what can happen, meaning this has happened all across the glacial lake states in the upper Midwest and the Northeast, where our lakes have become very developed. So here's a overhead image of a lake in 1938. And now what I'm going to do is put over it what the lake more looks like today from 2014. So this shows the dramatic fashion that our shorelines can change. And so having data, for example, through Score the Shore, that can now help us get a better understanding about when someone says, hey, our lake is changing, things aren't looking right. Well, we might look at the shoreline to help us understand what's happening in the lake itself. Tamara will be talking about dissolved oxygen and temperature later today, so I'm just alluding to it here. But as many of you know, our lakes change through time. You may have heard of lake turnover or mixing. My lake is mixing right now, and that mixing in our deep lakes often happen in the spring and the fall. And in the in-between months, which is summer and winter, our lakes actually stratify. And what that means is when the sun is beating down on our lakes in the summertime and the atmosphere is warm, the top part of our lakes are becoming warmer. And that warm water becomes less dense and floats on top of the cold water below. And that's what we're seeing in this picture here is we have this upper part of the lake that's nice and warm. We call that the epilimnion. And then we have the metalimnion, which is where the zone of transition occurs, this really fast zone. We also call this where the thermocline is. And then you dip down into the cold, dense waters of the hypolimnion. And I'm guessing many of you have swam in lakes and have experienced thermal stratification, where you've jumped into the water and have experienced it was really warm and then got really cold really fast. And so you've gone through the thermocline there. And so measuring this information is very important to understand if there are nutrient releases from the sediment. It indicates where different species of fish and organisms can live, and then also a whole lot more. And then finally, the exotic aquatic plant watch. This is a picture of a European frogbit. This is a newer invader into our inland waters here in the state. And it's It's now moved into Wisconsin and Green Bay as well. So if anybody is as Joe is talking about, people in the Western UP, it's now closer to the Western UP than it had been in the past. And so this is a floating leaf plant that Joe and I will be talking about more. And the idea behind the exotic aquatic plant watch is if we can find a species before it becomes established, meaning fully grown in a lake, we can usually eradicate it. But if we don't find it early, it can become established, spread, and it becomes very expensive and very difficult to manage and control. So we are in a training program today. And so we're going to walk through all of our training parameters except for aquatic plant mapping. People involved in aquatic plant mapping will get an email from myself in the future talking about potential future trainings to make sure that we are all set there. But next up will be Secchi disc water transparency.